The majority of transfemoral amputees wear prosthetics, which require a lot of effort. Here in Tuscany, researchers are testing exoskeletons that could change their lives.
We're at the Don Gnocchi Clinic in Florence, which Daniel drives to frequently. Daniel Bellini lost a leg 15 years ago in a farming accident. He's now a volunteer for a European project which aims to make life easier for amputees like him. This robotic leg is one of the prototypes. After only 2 sessions, he can already manage to climb stairs step after step.
With the prosthetics I usually wear, this is not possible. I have to stop at every step because the knee is just a suspension. When I go down the stairs, it does absorb the shock, but it doesn't give the power needed to go up the stairs.
He's joined by Besa Abderrahman, another transfemoral amputee. He tries on a pelvis exoskeleton prototype. When he wears it, researchers measure that his physical and cognitive efforts are reduced.
Lower
limb amputee patients waste a lot more energy to walk than other people. The aim of this pelvic active brace is to give the necessary energy to make their walk less tiring.
Scientists are developing a full-stop mechanism on the same exoskeleton. In 0.3 seconds, the brace identifies and then corrects the loss of balance, triggered here by this slip simulator system. Researchers from a wide range of fields at the Bio-Robotics Institute in Pontedera study the parameters of walking and transfer them onto their robots.
You want the system automatically understand what you want to do. And that's the reason why in this robot we need to put some cognitive ability.
It's partly here that the bionic leg was designed. The 2 motors on the ankle and the knee anticipate the moves of the amputee, thanks to sensors tracking his movements placed strategically.
2 insoles, one that is placed on the prosthesis and one that is placed on the healthy leg. And then we have 7 inertial measurements units. All this data is collected and is actually stored and processed inside the prosthesis. So we are measuring what the limbs are doing exactly, where they are and how they are moving. And based on this information, we compare it to the model. We know if the user is walking, if he wants to take stairs, or if he wants to stand up from a seated position, for example.
These technologies go well beyond helping leg amputees, as shown by this arm brace, or this bionic hand, which would allow quadriplegics, for example, to grab objects.
You know that you are developing enabling technologies that can be somehow used also in other domains, like with other kind of patients in the healthcare domain or in industry for helping workers to relieve from excessive fatigue, or applications in the broader consumer market. And here, of course, we can imagine that maybe young guys can come with crazy ideas that we can explore in the next years.
In Florence, the test phase continues. If the good results are confirmed, the 2 robots will be marketed in the next few years.